So the next use we can put our try except blocks to is to tidy up our code a bit. And if you remember some of the hub examples, we've used a function called has attributes, in other words, to check whether a particular device has a particular method. So is it possible to turn the spotlight up? And yes, it is, because it's dimmable. So it has a dot up method, dot up function. Or is it possible to play the music player with music player.play? And we can check that by using hasAttra. Let's find some code that does that. So from last week, there's the hub 06, and the controller has exactly that functionality. Let's make that a bit bigger. There you are. You can see once we've decided what the device is, we look at the command to see if it's got this on, off, up, down, play, pause are in the command, and then for certain of those, for on and off, we know that all devices can be switched on and off, so that we don't need to check. But for anything else, we check whether or not the device chosen has that attribute, up, down, play, pause, and so on. Obviously, the more devices we have and the more different functionalities they have, this could get increasingly more complicated. So what we can do instead is use the device and the method selected, and we try and run that code. So we would try and use musicplayer.play. If it works, that's fine. If it doesn't, it'll throw what's called an attribute error, and we can catch that and then tell the user that that wasn't possible. So we get this attribute error if the device doesn't have that particular method. So here's the cleaner version of that code. You can see there's the code. It's pretty much the same, except there's now no hasAttra tests here. We don't have to check, unlike this old one where we have to check whether the device has the particular command or not. None of that is necessary, because if we try and call a device that doesn't have that attribute, then it will throw an attribute error, and we can catch that with our except statement down here, and then we can print out, sorry, you can't do that. So for example, if we try with the heating you can turn on, so this would be fine. The heating you can turn up, that would be fine, but you can't play the heating. And so you get this, that would throw an attribute error, and then we catch that and say, sorry, you can't do that. And as far as the user's concerned, they don't see any of that that try except they're just seeing that they're doing different features and finding that one of them works, one of them doesn't. So it's a nice way to deal with it. And again, this code, it only catches the attribute error. So anything else, like memory error, if it ran out of memory, or if it was the device was inaccessible or something, they'll still generate a traceback. So we'd have to handle them as well. Okay, just while we're mentioning that, so that's quite a nice use of this technology, these try except statements to clean up our code, and it's quite a Pythonic way of doing things. It's an example of what's called duck typing, and in some programming languages you can't do this. So in some programming languages like Java, C#, you have to say what a variable is. So you have to say, if you're dealing with a spotlight, you have to tell Java it's a spotlight. If you're dealing with heating, you have to tell Java it's some heating. In Python, you don't have to do that, and Python also works on this principle that you can, rather than being explicit about what everything is, you just try something out, and if it works, fine, and if it doesn't, if it works, then you assume that was okay. It was okay for that to work, and if it doesn't, then you can put something like this try except in to handle it. And this idea is called duck typing, and the name comes from the saying, if it walks like a duck and it quacks like a duck, then it's probably a duck. So in some languages, it's very explicit about what you're able to do, because you know that that particular variable has certain attributes and has certain features, has certain methods. In Python, you don't know any of those things, but if it works, then you assume it's a thing that was able to do that. Okay, let's finish this video there, and then we'll look at some of the common exceptions you might encounter.